Okay, in this section, we're going to talk about the counting formulas. There's three important counting formulas we're going to talk about. The first one is the multiplication rule. This is where we just multiply the number of outcomes possible for each series of events, number of possible outcomes. So here for the main dish, I have 4 possible outcomes. Then I multiply that by the number of possible outcomes for the side dish, 3 possible outcomes. And then I multiply by the number of possible outcomes for desserts, 2. So I have a total of 4 times 3 is 12 times 2. So I have 24 different meal combinations I could offer my husband. Okay, let's look at permutations and combinations. So for permutations, order is important. For combinations, order is not important. Okay? So permutations, order is important. Combinations, order is not important. So for permutations, let's say 10 students go out and run a race. And if first prize obviously is going to be something like a big Reese cup, and second prize is only a piece of paper or something, and third prize is a pen, you're going to try harder if you really want that first prize. So if you have 10 students that go out and race, and let's say John really wants the first one, and he comes in first, and Betty comes in second, and Joe comes in third. That's one possible way of getting first, second, and third. Well, let's say if Joe comes in first, John comes in second, and Betty comes in third, even though it's the same 3 people, it's a different order, right? So that would count as a second possible way they can come in first, second, and third. So that's why the order matters. So for a permutation, we take n as our sample size. So we have 10. We calculate our permutation. And because on this one it's first, second, and third prize, there's 3. Our R is equal to 3. Again, n is your sample size and R is your how many you're trying to choose. Okay? So in this formula, we use what are called factorials. So we use n factorial divided by n minus r factorial. So n minus r is 10 minus 3 factorial. Or we have 10 factorial over 7 factorial. So now you might be saying, okay, I have no idea what a factorial is. A factorial is where we take the number and we multiply it by every integer down to 1. So in this case, it would be 10 times 9 times 8 times 7, times 6 times 5 times 4 times 3 times 2 times 1. So 7 factorial would be, you got it, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so you'll notice these cancel, right? So I'm left with 10 times 9 times 8, which is 720. Okay? Now, there's an easy way to do this on our calculator. Let me move my calculator over here. Okay? Remember I told you my favorite button is Stat. So my second favorite button is Math. Let me turn it on here. Oops, sorry about that. So Math is my favorite button. Now you're going to arrow over to PRB right here. And do you see you have this NPR and NCR? So we want the permutation NPR. Now, before we choose that one, if you click down on it, you'll see it just puts it in. But what we have to do is we put our N in first. So you want to type in your N first. So our 10. Again, go to Math, over to PRB, and down to number 2, NPR. And then the R we wanted was 3. Hit enter, and look at that. You get your 720. Okay? So, do you really need this complicated formula? I'm not going to ask you to show the formula out. You can use your calculator to get that. Now, if the question asks you, what's the probability that John, Betty, and Joe, John comes in first, Betty comes in second, and Joe comes in third, our probability of that happening, John in first, be very specific, then Betty, and then Joe. In that order, there's only one way out of 720 possibilities. Does that make sense? Okay, now combinations, the order doesn't matter. So let's say I asked John, Betty, and Joe, 3 students, to help me carry books. It doesn't matter if I ask John first or Joe first. It's the same group. You only count that once. So you can see combinations would be smaller than permutations. So let's say I have 10 students and I ask 3 of them to help me carry books. This would be 10 combination 3. So you can see the formula is just slightly different, but let's go ahead and put it in our calculator. We put in 10, go to math, over to PRB, down to NCR, and then put in our 3, and there's 120 different combinations. So again, if it asks you a probability and there's only one case, you'd be 1 out of that. Make sense? Tree diagrams display the outcomes of an experiment using a series of activities. This is another type of counting technique to tell us possible outcomes. So a tree diagram, we start with showing the possible outcomes. So for example, let's say we have a bag that has both red and blue marbles in it. Let's say our bag has 6 red marbles and 2 blue marbles, okay? So how many total marbles do we have? We have 8 total marbles, right? So let's say we're going to draw 2 marbles out without replacing the first one, and we want to draw a tree diagram of our possible outcomes. So we have what's called this initial node as our starting point. Now, I draw my tree diagrams off to the side like this. And sometimes, like in your homework, I think it'll be down. Okay? So on our first draw, we could draw a red marble, right? Or we could draw a blue marble. And then when we draw that red marble, since there's 6 red and there's a total of 8, the probability would be 6 over 8 of drawing a red marble. Does that make sense? And then the probability of drawing a blue marble is 2 over 8. Okay? Now, if we draw the marble, when we draw our second marble, this is our first draw here. The second marble, we could draw a red marble or a blue marble. So what this second branch is telling us is the possible outcomes on our second draw, or the second part of our experiment. So we could have a red or we could have a blue. Now, if we're not replacing it, if on this draw, right, we're drawing a red marble, this is assuming we already took a red marble out. Well, if we took out a red marble, now we only have 5 red marbles left, right? For a total of 7 marbles. So our probability on the second draw, now we'd have 5 possible red marbles out of a total of 7 marbles. Does this make sense? First draw, and then we want to look at the second draw being a blue marble. Again, we took out 1 red, so we only have 5 reds left. But now the probability of getting a blue marble, there's 2 blue marbles out of only 7 marbles left. Does this make sense? So then down here we can do the same thing. This time, we take out a blue marble. So we only have one blue marble left. So the probability of getting a red marble is still 6, but out of 7 this time. The probability of blue marble now is only 1 out of 7. Okay, makes sense? Okay, so, oops, sorry, I lost part of my line there. When we go to calculate our probabilities, if we start with the initial node, okay, and we follow it from the beginning here into the end, this is saying we want the probability of getting a red marble on the first draw and a red marble on the second draw. So that means probability of red on first draw and red on second draw. So when you follow your path from the beginning to the end, that's the multiplication rule. So we have the probability of red on the first and red on the second is 6/8 times 5/7. Okay? Or (30/56). Does that make sense? Okay, now if we use a different path, let's say we want to know the probability of getting at least one red marble. Well, then we have some options, right? We can get a red on the first and a red on the second. That would be one possibility, which we just calculated to be 30/56, right? Or we could get a red on the first marble and a blue on the second. That's still one red. So because we're saying or, we're going to add that. Okay? But to get what that probability is, red on the first, blue on the second, we follow our path from the start to the finish. We have to multiply 6/8 times 2/7. Okay? Or we could get a blue on the first draw and a red on the second. Okay, so because that's an or, we do plus. But this pathway is blue on the first, red on the second. We need to multiply. So we have 2/8 times 6/7. Okay, so we end up with 30/56. My pen's failing here. Plus 12/56. Plus, again, 12/56. So we end up with 30 plus 12 plus 12. What is that? 54/56 is our probability of getting at least one red marble. Make sense?